Today we're going to talk about solving equations with models and combining like terms. So models are just picture representations of an equation. And remember, equations have an equal sign. And we're also going to practice combining like terms. And like terms just means putting stuff that matches together. So you can see like all of our letter J's are circled and all of our constant regular numbers are boxed. Okay, so we're going to practice those things. So fold your notes in half and let's get started. So we're going to start with solving equations with models. So this is a model of an equation. You can see it's a picture representation of our equation. So first thing I'm going to do is I'm going to write my equation down. So I'm going to count and I'm going to say, okay, how many x's do I have? I have 1, 2, 3, and 4. So I'm going to write down 4x. And then I have some positive ones here. So I have 1, 2, 3, 4 positive ones. And so again, those were positive. So I'm going to put a positive 4. And then we have our equal sign here in the middle, right here. And so I wrote my equal sign, and then I'm going to count how many positive ones I have on the right. So 1, 2, 3, 4, 5, 6, 7, 8. So in my equation, that equals 8. All right, so now I'm actually going to use my model, and I'm going to make it simpler. I'm going to simplify it, and I'm going to do that by eliminating anything that matches on both sides. So anytime we have matches on both sides of the equal sign, so here's our equal sign, that's our wall, okay? Anytime we have matches on either side, we're going to eliminate them. So we have some positive ones here, and we have some positive ones here. So for every positive one that matches, I'm going to eliminate it. So I'm going to eliminate 1 and 1. 1 and 1. 1 and 1. 1 and 1. And again, I'm doing that because they match, and remember the equal line is our middle. So if they match on both sides, we're going to get rid of it. So now I'm going to rewrite my simpler equation. So this time, how many x's do I have? Well, I still have 4. Okay, so my equation is now simpler. And now I have just an equal sign because the ones have disappeared on this side. And now on the right side, I have 4 ones left. So I made a simpler equation just by eliminating anything that matches. So basically, what did I do on this side? Well, I took away 4 positives, so I subtracted 4. And then what did I do on the other side? I did the same thing. I took away 4 positives. So what did I do? I subtracted 4. So anything I do to one side of my equation, I have to do to the other. So I made a matching subtraction of 4 on each side. All right. So now let's take our simpler equation, 4x, and 4x just means 4 times x. Remember, when a letter and a variable and a number sit next to each other, they are multiplying, and then equal sign, and then we still have 4. All right, I'm going to draw my line down my equal sign to keep my wall. And remember, anything I do to one side of the wall, I need to do to the other. So what are they doing to my letter x? Well, my goal is to get x alone, to make x a variable by itself. So I have to get rid of that times 4. So what is the opposite of multiplying by 4? Well, that is going to be dividing by 4. And remember, if we do it to one side of our line, we have to do it to the other. What happens to the 4's on the left? Well, they cancel out because multiplying and dividing are opposites. And that leaves me with my x all by itself. And then what is 4 divided by 4? Well, 4 divided by 4 is just 1. So what is my solution? My solution is x equals 1. So how could we check that with our picture? Let's go back and let's see. Over here on the left, we had 4 groups of x, right? Here's a group of x, group of x, group of x, group of x. And so let's see if I make 4 groups on the right side, does that equal 1? So if I divide this into 4 groups like so, How many are in each group? Well, that's 1 positive in each group. And so that matches. All right, let's try the second problem. So our second problem, we have a key this time, so we can look and we can see, okay, so my shaded in rectangles are going to be equal to x, and my white rectangles are going to be equal to negative x, and then my little white squares are going to be equal to positive 1, and my gray squares are going to be equal to negative 1, all right? So I need to go ahead and write my equation right now. So remember the white rectangles are going to be a negative x. So how many negative x's do I have? Well, I have 1, 2, and 3. So I'm going to start with negative 3x. All right. And then what were the white squares? Well, the white squares were a positive 1. So how many positive ones did I have? I had 1, 2, 3, 4, 5, 6. So I have a positive 6. And then I have my equal sign. And then my shaded in squares were negatives. So how many negatives did I have? I had negative 1, negative 2, and negative 3. So that's going to equal negative 3. All right. And so now I'm going to check for my equal line, and I'm going to go, okay, do I have anything that matches on both sides of my equal sign? Well, no, right? Because I have some white rectangles, but I don't have any white rectangles over here. And I have some white squares, but I don't have any white squares over here. So because I don't have anything that matches, I can't eliminate anything, but I can move everything away from x. So I'm going to take these ones and I'm going to move them to the other side, okay? I'm going to move them to the other side so that my x's, my variable, is alone, okay? Because that's our goal, is to get our variable alone. See, we got our variable alone up here. So how do I move it if there's not anything to cancel out? Well, I'm going to draw to make it cancel out. So how do I move a positive 1 over? Well, in order to get rid of it on this side, I would need to subtract 1. And so then I'm going to have to subtract 1 on this side. All right. And then so that one's gone. And then to get rid of this one, I would have to subtract 1 because 1 minus 1 is 0. And so again, I would have to subtract 1 on this side because anything I do to one side of my equal sign, I have to do to the other. So I continue to do that, taking away 1, right? Making them cancel out, taking away 1, taking away 1, taking away 1. And so I end up moving all 6 of those positive ones over. And remember, they have to flip their sign because we had to make a 0 pair and cancel them out. So we had 6 over here, and now we have 6. So again, that represented minus 6 over here, and these that we drew, that also represents minus 6. So again, matching on each side of our equal sign. So now that my variable is alone, let's rewrite our equation a little bit more simply. Okay, so how many x's do I have left? Well, I still have all 3 of my negative x's. So I'm going to come down here and say negative 3x. But this time, all my 1's are gone, so I have my equal sign. And then I need to count what's left over here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and those are all negative. So I will write negative 9. All right, now that I have a simpler equation, I'm going to come over here to the side and I'm going to solve it. So I have negative 3x equals negative 9. And remember, when a number and a letter sit next to each other, that means to multiply. So I'm going to put my little multiply dot in the middle there. I'm going to draw my line down my equal sign because remember, anything I do to one side, I have to do to the other. And I ask myself, what is the opposite of multiplying? And so the opposite of multiplying would be dividing. So I'm going to divide both sides. And what am I dividing by? Well, I'm dividing by whatever's next to x. So in this case, -3. So I'm going to say divide by -3, divide by -3. And so then I cross out, because once the multiplying and dividing cancel each other out, this goes away. And all I have left is my x value, which is our goal to get x alone. And then on this side, we have 9 divided by 3, but they're negative. So because they're negative and we're dividing, I'm going to need integer man to help me out. Both numbers are negative, so I'm going to scratch out both of his i's, and I end up with +3. So what is my solution? X equals 3. X equals 3. All right, and again, we could say, if we divided this, so we had 3 groups here, we could just double check ourselves. We had 3 groups of -x, so if I were to divide these into 3 groups, I would have, oh, there's groups of 3, and yep, that works, because the negatives on each side cancel each other out, and that's where we get our +3 from. All right, looks good. Let's try our next one. So our next one, example number 3. I'm gonna scoot on up here. So example number 3, we have a scale balance. So when you have a scale balance, there's no equal sign, it's invisible, so we're just gonna go ahead and write it in before we get started. So anytime we have a scale balance, the equal sign is the middle of the scale, okay? So remember, we draw our line just to make sure that we're doing the same thing on both sides of our line. And remember, anything that matches, we can eliminate, we can cross out. So I look and I say, do I have anything that matches the positive ones on this side? No, because these are negative ones, so they don't match. Do I have anything that matches the x's? No, those are all ones. And do I have anything that matches the negative ones? No, these are positive ones. So I can't do any eliminating, but I can do what I did up here, and I can move these negative ones to the other side and isolate my variable, get my variable alone. So how did we move our ones up here? Well, we did the opposite. So how would I make -1 into 0? Well, to cancel it out, I would need a +1. So a +1 and a -1 make 0. And so remember, I need to do the same thing on this side. So I'm going to add a +1 little block. And so again, that's matching on each side. So I added 1 here to make 0. So I'm going to add 1 here. And again, same thing on both sides. So again, how do I make that -1? I'm going to add 1, so I'll draw another 1 little block, and those cross out. How do I make that -1? 0 to make it go away. I do a +1, so again, I'll do another +1 block, and those are gone. A +1 block for that one, and those are gone, and a +1, because 1 minus 1 is, again, just 0. So what did I do? Basically, that comes down to I added 5 here to make those negatives go away. I added 5 to make a 0. And then again, I added 5 on this side to make my balance stay equal. Okay, got to do the same thing on one side as the other. All right, so now that I have, oops, I never wrote my original equation. Let's go back and do that real quick. So on this side, originally I had 1, 2, 3, 4, 5, 6, 7. So my 7, and then I had my equal sign. And then I had 1, 2, 3, 4 x's. So I would have 4x. And then we had some negatives this time. So how many? -5. So then I would write -5. So now let's write our simpler equation now that we've moved some stuff around and we've isolated our variable. So on this side, we now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and those are positives. So I'm going to start with +12. My equal sign, and then how many x's? 1, 2, 3, 4, and remember, these are all gone. Okay, so we have 4 x's. And now we have a much simpler equation. And so I can come over here to the side and say 12 equals 4x. Remember that we always draw our line down the equal sign because anything I do to one side, I have to do to the other. Remember that when a number and a letter sit next to each other, that means to multiply. And so how do I get rid of multiplying? How do I undo multiplying? Well, the easiest thing to do there is the opposite of multiplying is to divide. So I'm going to divide on both sides. What am I dividing by? I'm dividing by the number in front of the letter. So that's going to be a 4, and it's positive. So divide each side by 4. What happens on the right? Well, the multiply and the divide cancel each other out. So that leaves us with just x. And 12 divided by 4 is just positive 3. So again, x equals 3. And so that is solving with models, okay? So let's scoot on to the next page, and we will talk about combining like terms. All right, so combining like terms, the thing we have to look at is we have to look at the back. So in the back here, we have an x and an x. Because these x's match, I can combine these terms. So these are alike because they both end in an x. And so literally we just add. What is 4 plus 3? That would be 7x. So if you wanted to think about it instead of a letter, think about it like an animal at the zoo. Let's call this 4 monkeys and 3 monkeys. So that's 7 monkeys, right? Like if that makes it better for you, that's fine. If you want to talk about animals on the farm, you could say, okay, I have 4 chickens and I add 3 more chickens. That's going to be 7 chickens. Okay, so if the X is throwing you, replace it with an animal or something else. All right, so next, let's check out our next one. We're going to look at the back. This time we have XY and XY. Well, again, those match. So these are alike. And because they are alike, we can just combine the front numbers. Well, we have a positive 5 and a negative 8. So I know that I need a positive negative table. And I know that 8 is going to win because it's got more power, the team negative. So 8 minus 5 is 3. And again, negative 1. And we keep the XY at the back. All right, our next one, we're going to check out what's at the back. Well, we have an X and we have a Y. Those are not alike. They are different. So because we have one X and one Y, we can't combine them. That's like saying, oh, we have 5 chickens, but we also have 3 cows. Okay, you can't combine cows and chickens. They're different. So because they're different, we don't put anything in the combined. We can't combine things that don't match, okay? So we won't put anything in the combined area. All right, our next numbers are just regular old numbers, right? We have a 4 and we have a negative 2, and we've been combining those since last year in 6th grade. So these are in fact alike because they are both just basic numbers. And so I know that one of them is positive and one is negative, so I need my positive negative table. I know that team positive is going to win because 4 is greater and they're different, so I'm going to subtract. 4 minus 2 is 2. There's no letter because there was no letter on my original numbers. All right, let's look at the next one. So the next one, we have a number with a letter, but then we have just a regular number. Because they don't have the same last piece, we can't combine them. So the X here, but no X here, these are considered different. And so again, we cannot combine things that are considered different, okay? So that's like saying, oh, I have 5 zebras, but then I have $2, right? Like those don't make sense. We can't combine those things. So we would not put anything in our combined area. Those cannot be combined. All right, if we keep looking, we're going to check out the last piece. We have an m squared and an m squared. So those match. So because they match, they are considered alike, and we can combine them. So we have a positive 3 and a negative 6, and negative 6 has more power. So I know my answer will be a negative. 6 minus 3 is 3. And then we keep that last piece, the m squared. All right, and our very last one, we check it out. We got an x squared and we have an x. Well, these look like they might be a match, but they're actually different. And the reason being, if I considered these, let's say I have 4, again, zebras. So 4 zebras. Well, those are 4 regular zebras, but these zebras, okay, they're sick. These are 3 sick zebras because they have the little squared, okay? That makes them different. And so we can't put the 6 zebras in with the regular zebras. So those are considered different. And again, we would not put anything in our combined because we can't combine them when they have different base numbers. All right, so let's practice. I want you to box anything with a letter, okay? And I want you to circle regular numbers. So if it's a regular number, I want you to circle it. And if it has a letter, a variable, we're gonna box it, okay? So I'm gonna start at the back and I'm gonna circle and I'm gonna say, okay, that has a letter, so I'm gonna use a box. And I boxed all the way from the back to the back of the next number. All right, and then the next number doesn't have a letter, so I'm gonna circle. And I circle all the way from the back of the number 2 to the back of the Y. And then I check it out, the next number has a letter, has a variable, so I'm gonna go back to my box and I'm gonna box my number. And then I'm gonna go back to my number 9 and I'm gonna circle. All right, and then I'm gonna combine my like terms. So everything that's in an orange box can be combined. So I have a 7y and I'm gonna take away a 5y. So 7 minus 5 is 2y. And then I'm gonna grab my circled numbers. So over here I have a 9 and I'm gonna take away a 2. And 9 minus 2 is going to be a positive 7. And so I have combined my like terms. And then we're gonna move to example 2. So in example 2, we have 8w minus w. So anytime you have a letter that sits by itself, it's actually a 1. So if I use that w as a watermelon, I have 1 watermelon. So if I have 8 watermelon and I take away 1 watermelon, how many watermelon do I have left? So remember, these are both letters. So I'm gonna start by boxing them. And I box both. So I don't have anything else to combine except for my w's. So 8w minus 1w is just 7w. And that's all done. And then my last example, I have 4r plus negative 3r. So again, they both have letters. So I'm gonna box from the back to the back of the other letter. And I box the front. They both are boxes, so we can combine them. Just like when we follow our integer rules, we're gonna go ahead and say these have a positive and a negative. We're gonna keep the negative 3r, and at the front we'd have a positive 4r. So if I have 4 raccoons and I take away 3 raccoons, how many raccoons do I have left? I would have 1 raccoon left. And remember, if it's 1, we can write it as with a 1, or we can write it as just the letter. And that is how we combine like terms. All right, guys, go practice.